Alright, so today's section we're going to talk about section 7.1, which is our section that has to do with confidence intervals, and it has to do, we're going to pretend that we know some things about our population. Before we start talking about confidence intervals, we need to talk about estimates and estimation just a little bit in general. So I'm not going to write for a little bit, I'm just going to talk and see how this goes. But oftentimes when we read statistics and the commercial says 4 out of 5 dentists prefer Crest or Colgate or whichever brand we happen to be watching the commercial for, that doesn't mean that they have actually had the time to survey and talk to all however many dentists there are in the nation, or whatever their population is. It's not possible to talk to every single dentist in the country. So what they do is they take a sample, sometimes a very large sample, and then they use that as an estimate or as an approximation to make an assumption about what the whole group, how the whole group feels about things. When we initially start, and before I actually start into this too far, I'm going to tell you please read the section from beginning to end, because I'm going to try to hit the highlights and keep these videos to about 10 minutes. Probably there will be 2 of them, but the details are really going to be left in the text. When we start our estimation process, we start by using what's called a point estimate. A point estimate, when we talk about a point, it's a single number. So we can say that we did a survey and we found out that the mean from that sample is a certain value, or that the median or that the mode holds a certain value. As far as estimating goes, however, the mean is the one that's the least variable. It's the best point estimate to use when you're talking about averages. So typically when we talk about a point estimate, it's going to be exactly equal to the mean of whatever sample that you were looking at and using. Oops, my cord's getting hung up here. There we go. So if you're reading in these problems and it asks you specifically for a point estimate, know that it wants a single number, and the only number that we really have to estimate the average from the information that you'll be given will be the sample mean. Okay. What we're going to do is use that sample mean to come up with what's called an interval estimate for the population. Now, all of this is done when we look at a sample, even if it's a very large sample, is we're trying to gather enough information that we can infer, this is inferential statistics, that we can infer what would happen to the population as a whole. Nope, that's not going to work. It's not going to go back either. With our intervals, there are multiple pieces. One is that we have to determine how confident we want to be that we're close to that mean. Okay, we might, and we will quantify that. We'll say we want a 90% confidence level or a 99% confidence level. We also so let's start there. The more confident that we want to be, means that our interval is going to get bigger. Okay. In order for me to be more positive that I'm correct, I have to make the area and the range that I'm covering, the amount of space that I'm covering, I have to make that bigger, so I'm sure and I can be that confident that I've hit the value that I want. Now, all of our confidence intervals, that's what we're building up to do, confidence intervals. Our confidence intervals are all going to be centered around our sample mean, and they are going to again get bigger the more confident we want to be, or they'll get a little bit smaller if we're okay with being less confident. We're also going to talk about the error and sample size and how those two things relate to each other. Excuse me. Okay. Now, depending on how confident we want to be, and the book kind of skirts over this pretty quickly, I think. But if we look back to the central limit theorem, it tells us that 68% of our data typically falls within one standard deviation of the mean. This was back in chapter 2 or 3, I think, that this was brought up. If we move to 2 standard deviations away from the mean, then our data, it holds 95%. And if we go to 3 standard deviations, I think it's 99.7% of our data will lie there. If we draw our picture and we use our z-scores and we want to find that middle 95% of data, then we know that the area in the middle is 95%, 0.95. We can go backwards and we can figure out what those z-scores are. One will be positive, one will be negative. There'll be opposites there because of the symmetry found. But our book was very nice to tell us that for a 90% confidence level, our z-scores that we use are going to be 1.65 if we look at just the positive one. If we want to be 95% confident, it is 1.96. And if I want to be 99% confident, then our z-score is 2.58. Now, if I asked you to find a confidence interval with 80% confidence, or 93% confident, or 99.5% confidence, we would have to go through and by hand take this method, figure out our z-score, our positive z-score that would go there, and it wouldn't be one of these 3. But these are the 3 most commonly used. I glanced at your homework assignment, and they're the only 3 that you would need in doing your homework assignment. So these are values. If you need to circle them on your table, if you can find a way to do that, I don't know if you could or not. But these are 3 values that we're going to use over and over again. Now the idea, it won't let me scroll down. Is that if I want to create a confidence interval, I want to say that I am possibly 90% confident that the mean of my population is somewhere in between these 2 values, then the only thing that we're going to have to base this confidence interval on is the sample mean. So we'll be told a sample mean in the text, and then what we're going to do is create an interval with that mean being in the center. How we do that is we start with a sample mean and we subtract the z-score from up above on the list times the standard deviation over the square root of n. Okay. This gives us our low endpoint, our lowest value in our interval. If we want the high value of our interval, we're going to take our sample mean, we're going to add that z-score times the times the standard deviation over the square root of n. That'll give us our upper endpoint. This value here, the value that we add and we subtract from the mean, that's called our margin of error. And we're going to use it in a little bit to help us go backwards. If we know how close we want to be and find our sample size to get that done, we're going to get to go backwards here in a little bit. Okay. So I think this is going to be a good place to stop for now. Just a quick summary of what I've said is if we start with a point estimate, that means it's just a single value. The point estimate that we will use in this section, and the only point estimate we'll use, is the sample mean. We can use that point estimate to create a confidence interval. An interval where we can say with a certain level of confidence that the mean of the population, which is mu, not x bar anymore, but our mu is between these two values. We can be 90% confident that the mean is between here and there. If I want to increase that level of confidence to 99%, then my interval has to get bigger to be sure I can be that confident that I've actually encompassed the population mean. We will do some examples of that and also examples of finding the sample size if given the maximum error in the second part of the video.